Alrighty, good morning. Happy Tuesday. I know yesterday was extremely stressful with everybody trying to figure out the assignment. So I did post a video on my YouTube channel that has all the answers for the assignment, and I'm talking in detail and giving you step by step how you would find those answers. If you have any more questions about that, please bring them to the session that I'm going to have on Teams at 10 a.m. on Wednesday. So make sure if you have any questions about this section that you bring your questions to that session at 10 a.m. on Wednesday, because that will be the last time that you can ask me questions, because you have a quiz on Thursday. And on Thursday, the quiz will only be on 15.2, and I think in 15.2 there was only one vocab word. So it's everything on 15.2. So we are going to finish up the very last section of this section of 15.2. So we're going to be talking about energy and mass. And what I want you to do is turn to page 459. So while I'm going over this, you can kind of follow along in your book and make sure you have your outline that I had you do with you. So we're talking about Albert Einstein, and he decided to come up with this formula that E equals mc squared. In the formula, E is going to stand for energy, and energy is clearly going to be in joules, the unit. M is going to be mass, and that's going to be in kilograms. And then C is the speed of light, and it is known, and I will give it to you in a problem, that the speed of light is 3 times 10 to the 8th meters per second. So what this formula is basically saying is that energy and mass are equivalent and can be converted into each other. Well, in other words, basically it's saying energy is released as matter is destroyed, and matter can be created from energy. So I want to pause right there and go into the book, and it's talking about how the speed of light is an extremely large number, and so it's trying to have you compare that, and it says that a tiny amount of matter can produce an enormous amount of energy. So it gives us this problem. It says, suppose 1 gram of matter were entirely converted into energy. So we're taking that matter and turning it into energy. And it says that the mass is 1 gram, but remember we have to have it in kilograms, so it would be 10 to the third, negative third. And then you would multiply that times 3 times 10 to the 8th, and you're going to square that. And in the book, it shows you how a tiny piece of matter ends up giving you this enormous amount of energy. So you can see in the problem that the amount of energy is 9 times 10 to the 13th. So what I want you to know, and basically for this, we're not going to go into a lot of detail. I want you to know what the formula stands for. So I want you to know what E stands for, what M stands for, what C stands for. You should be able to give me the units of all those. And then I also want you to be able to tell me what this formula is saying. And that is basically that energy is released as matter is destroyed, and matter can be created from energy. That is all I want you to know about this. I'm not going to go into too much detail about it because it's a little bit trickier to explain. So I'm telling you exactly what I want you to know, so please do not dig into it any deeper. All right, the next thing that I want to go over is on page 461. And maybe I should have gave you, oh wait, sorry. Before we go there, let me do a practice problem with this equation. So the practice problem is, how much energy can be created from 50 kilograms of matter? The speed of light is 3 times 10 to the 8th meters per second. So we know our formula is E equals mc squared. E is going to be our energy, so we just plug in our answers. So 50 is going to be the mass, and then we know that the speed of light is going to be 3 times 10 to the 8th, and we have to square that. You plug that into your formula into your calculator exactly how it is on the screen, and your answer would be 4.5 times 10 to the 18th. Make sure, and the unit for that would be joules. Make sure you plug it in exactly how it is shown on the screen. That is an example of a problem that I could give you on the quiz. Basically, I would give you the mass, I would give you the speed of light, and then you would just have to plug it into the formula and tell me how much energy you would get. All right, this is the problem that I really want to concentrate on, and this is dealing with, oops, sorry, we're not there yet. The roller coaster. And maybe it's my fault that maybe I should have gave this to you a little bit ahead of time before we did the assignment. But I mean, hey, we all learn from our mistakes. But thank you for a lot of you that reached out to me and you were saying how confused you are. That gave me the opportunity as a teacher to FaceTime a lot of you guys yesterday and talk you through the steps. So please, guys, this is going to be huge for you to communicate with me during this time. If you're not understanding anything, we can hop on and we can do a FaceTime or a video chat, and I can go over it one-on-one with you. So I'm going to talk about the kinetic energy, potential energy of this roller coaster. As you are going up the hill, all right, so the cart's going up the hill. As you are going up that hill, you are gaining potential energy. So you're going up, you're gaining potential energy. At the very top of that hill, you are going to have your max potential energy. If you have your max potential energy, you are going to have no kinetic energy. So when you are at that top of that hill, you are going to have your max potential energy and you are going to have zero kinetic energy. As soon as that cart starts to go down that hill, that potential energy is rapidly going to change into kinetic energy. For problems 3 and 4 on the assignment, I said halfway down the roller coaster, potential energy and kinetic energy are going to be the same. You have to think because potential energy is rapidly turning into kinetic energy. So when you are halfway down that hill, it is going to be the same potential energy as there is kinetic energy. Once you get to the very bottom of that hill, that is where you're going to have your max kinetic energy. That means that you're going to have no potential energy. So at the bottom of that roller coaster, you are going to have your max kinetic energy. As you go around that loop, you are going to start to gain potential energy. So the kinetic energy is going to transfer into the potential energy. When you get at the very top of that loop up here, it's going to start rapidly turning into kinetic energy. And then as you go around the second loop, it's going to turn into potential energy to get you around that loop. And then it will go into kinetic energy. So let's do this one more time. As you're going up the hill, you're on your cart, hands up in the air, woo, going. You're going to go up that hill. It's going to be gaining potential energy. As you get to the top of that hill, you're going to have your max potential energy and you're going to have no kinetic energy. As you go down that hill, that potential energy is going to rapidly turn into kinetic energy. But remember, when you hit that halfway point, potential energy and kinetic energy is going to be the same. When you get to the very bottom of that hill, you're going to have your max kinetic energy and no potential energy. As you go around that loop, you are gaining potential energy. When you are upside down hanging at the top of that loop, you are going to have your potential energy that's going to turn into kinetic energy to get you around that loop. And then when you go into the second loop, you're once again going to gain gain potential energy, then it will turn once again into kinetic energy. You should be able to tell me where there's potential energy and where there is kinetic energy on this roller coaster. If you have any questions, once again, guys, I cannot beg you enough. Please bring questions so we can review this stuff on Wednesday at 10 o'clock on Teams. I will be answering any questions that you guys have for 15.2. All right, so today's assignment is to look at both of these videos, the one of the answers from the assignment and this one. Make sure you add these notes into your outline that you have already done for 15.2 and make sure that you bring lots of questions for me to answer. All right, guys, I miss you and I hope you're all doing well, and I'll see you soon.